This event itself is being held in collaboration with the Railway Industry Association, known as RIA. If you were on the last call, I mentioned that everything in the rail sector is acronyms, but RIA stands for the Railway Industry Association. So we're joined by David Clark, the Technical Director, and we've got Network Rail, we've got Kevin Raymond and Roger Moore here today that are going to present as well. Along with David, we've got Emily Kent, she's an SME who's been through the Unlocking Innovation programme, and she's going to tell you all about her experience of it. Just as a quick aside, if you haven't had a chance to get into Rail Event 1, it's really worth a look. We recorded it as we're recording this one. It's on the Rail Cluster web pages. I've put a link in the chat facility. It's definitely packed full of detail and well worth a look. So I'd encourage you to make some time for it. For those of you who don't know me, although I'm sure most of you do by now, I'm Shona Clive, project lead for the Rail Cluster Builder project. Oh, I think somebody might have their mic on, sorry. Anyway, I work for with the team at Scottish Engineering on the Rail Cluster project. I'm also chair of Women in Rail Scotland, and my previous role was with Babcock. I was head of marketing and communications at Babcock. This February, which was last month, was my 25th year in the rail sector. And I'm also, just as a wee aside, David Clark used to be my boss way back in First Engineering days. And so it's really nice to have him with me today and joining us. So thanks, David. A very quick canter through the Rail Cluster programme, just in case you don't know about it. It's an 18-month project jointly funded by Scottish Enterprise and the European Regional Development Fund. We're also supported by Transport Scotland. We've got several aims, but in a nutshell, our key purpose is to connect SMEs in the engineering and manufacturing sectors in Scotland looking to diversify into rail or grow their presence in the sector. And also we help facilitate links with the correct people or organisations within the rail sector. So that would be companies like Network Rail, ScotRail, Tier 1s, rolling stock manufacturers and the wider supply chain. The context of the Rail Cluster project is the Rail Decarbonisation Action Plan, it's a bit of a tongue twister, in which the aim is to deliver carbon neutral rail transport by 2035 and make Scotland a leader in creating net zero emission railways. If you haven't had a look at it, again, I would encourage you to go to Transport Scotland's website and have a read through it. It's a really good document. In terms of the rail cluster, we've got 448 individuals registered with us. That's 314 different organisations, and of these, 182 are SMEs. From a start position of 0 back in August last year, we're pretty pleased with these figures, and it's even better because the numbers continue to grow, particularly after an event or if we've issued a report or something. Part of the rail cluster activity involves one-to-ones with SMEs, and I've done quite a few of them along with Paul and John, and I can say that my eyes have definitely been opened with the scope and the range of expertise and skills that are right here on our doorstep in Scotland. The rail sector presents multi-sector diversification potential for SMEs, where there's synergies, or they may have a product or service that can be adapted to get into the rail sector. We've got companies from all sorts of backgrounds: aerospace, automotive, marine, oil and gas, renewables, and we have skill sets: steel fabricators, machine shops, precision engineers, instrumentation and controls, metal manufacturing, digital skill sets, technology businesses, even a seat covering company. So we have a wide scope. Moving on to today's event, I'm delighted to welcome David Clark, Technical Director from RIA. David will talk through the Unlocking Innovation programme and will explain how existing and potential rail suppliers can get involved with the RIA Innovation programme, which is developed with RIA's strategic partners, Network Rail and Ukraine. David will be joined by Emily Kent, co-founder of intelligent video specialist One Big Circle, who, as a new SME business, used RIA and the Unlocking Innovation programme to help them navigate the rail industry and make the connections that have enabled them to grow rapidly. Following on from David's session, Roger Moore, a Senior Product Acceptance Specialist, Network Rail, will provide an overview of the product acceptance assurance process. And then we'll have a quick 10-minute coffee break, because that will have nearly been an hour. We'll be online, and we'll return to hear from Kevin Raymond, Reliability Process Manager, Network Rail, who'll take us through the design for reliability process. We hope you enjoy this session. I'm sure it's crammed with information. We're recording it so that you can look back on it. It'll be on the Rail Cluster portal as along with the other events. And just before I hand over to David, really quickly, some housekeeping. We're going to, if you could switch off your video and mute your sound just while the presenters are speaking, so that there's no distraction for them, particularly your sound, please. Please use the chat facility to post any questions you might have. We'll run through the Q&As at each break once each section is completed. If we run out of time and we're running short of time, we'll follow up with the questions after the event, so they'll definitely get answered. And I think that's me concluded, and I'll pass over now to David from RIA. Thanks, David.
Thank you very much, Shona. It's a pleasure to be working with you again. I'll now share my screen, because I'm afraid there is a few slides involved here. So here we go. You should all hopefully in a second be seeing a screen. Can you hear me? Yep, I was muted for a second. Okay, so good afternoon, everybody. As Shona said by way of introduction, I'm going to talk to you about RIA's Unlocking Innovation Programme. So, as Shona's mentioned, we work on that in partnership with Network Rail and UCRIN, which is the UK Rail Research and Innovation Network, which is a collaboration of, well, it was eight universities and 16 suppliers, but that's expanded over the last few years. The important thing about the Unlocking Innovation Programme is it's open to all. You don't have to be a member of RIA to take part in the programme. So what does that look like? Well, to give you a flavour, these are the events that we've run over the past few years. We ran a series of programs that we termed Made in Britain. That's materials, automation, data and energy. And we ran events on each of those themes, and then we pivoted it, if you like, and we did Made for Infrastructure, Made for Rolling Stock. And then we moved on in 2020. Well, we were forced to by a small thing called the pandemic, and we moved into a different phase where we were delivering everything online, as you inevitably have to do. So historically, an Unlocking Innovation event is a high energy day. It's not really a conference. It's got a lot of things going on. Yes, there'll be some presentations, but there'll be workshops, there'll be networking, lots of networking. There will be an exhibition, and there will be one of the most popular things, and Emily might mention this, is elevator pitches, where we give a 3-minute slot to typically an SME to say words to the effect of, "Hello, here I am. This is what I'm working on, and the help that I need or the partner that I'm looking for is whatever." And those have been very, very successful. So as you can see, we run quite a few unlocking events. We did 5 last year actually. But we're now moving on to a slightly different theme, or in 2021. So the theme for 2021 is Railway of the Future. As I've already said, those are the sort of kind of characteristics of, at the bottom there of the slide, they're the characteristics of what a UI looks like. We've tried to replicate those as far as possible in the virtual events, which is easier said than done. You clearly don't get such good networking, but we're looking forward to getting back to physical events. But what does UI do? What it does is it tries to put in the same room the people, the clients and funders who've got the problems, the challenges that need fixing. It tries to put them in the same room as the innovators and suppliers who've got the potential solution. give them the space to have a few conversations, and then hopefully serendipity happens and we get a project out at the end of it. And we've got quite a few examples of that, one of which is Emily. And we're trying to run a balanced program, balancing it around geography, around the different clients, around the different parts of the rail system, and also looking shorter term and longer term. So if we're thinking about innovations, you know, when will they mature? So Shona talked about the longer range things that we need to think about with decarbonisation, for example. But clearly, let's face it, the focus is on getting things into the market as soon as possible. So what's this year's programme look like? So in February, we had an event around Building Back Better, and we did that in partnership with Innovate UK. They were running an innovation exhibition, and so we made it an all-day event. They had the morning, we had the afternoon, or vice versa, and we had well over 1,000 people attending that. It was a really, really strongly attended event. The next one, which, as I say, is open to all, so you can book now, and I'll show you in a minute how to do that, is Whole Systems for the Digital Age, and that's in May. We've then got data-driven maintenance in July. That'll be a hybrid event, we expect, so you'll be able to attend in person, or you'll be able to dial in as you prefer. We're then doing a whole program around rail techs and infraRail, and something for rail cluster members to be aware of. That is the big UK exhibition this year, 7th to the 9th of September in Birmingham. So we'll be there and part of it, and running a whole program of activities around that. Getting towards October, we're looking at COP26. So just before the COP26 in Glasgow, we'll be running a climate change and resilience program. We haven't decided on the venue yet. It'd be quite nice, wouldn't it, if that was somewhere near Glasgow? So that's certainly an option in our mind. And then at the end of the year, we'll be focusing on Network Rail's research and development program. So that gives you a flavour. On the right-hand side, there are pictures of previous Unlocking Innovation events. As you can see, we try and go to interesting, iconic venues where there's tangible stuff to see and look at and learn about. So how do you find out more and sign up? Well, if I just pull up the RIA website, of which there's a snapshot here, you can hopefully see the website when it finally winds up. Now, if you go to About Us and Unlocking Innovation, then you get a lot of information about Unlocking Innovation, including Natasha Kaplinsky telling you all about it. You then get what's the next event, how you get involved, etc. Bit of background, and the events I previously mentioned, if you click on UI events, so our back catalogue, as it were, is available. So you can look at the recordings of all the previous events. As you can see there's the lightweight and low cost railway. And the other thing to draw to your attention, so for those who aren't members of RIA, if you go to events and click on open to all, then in there are the things that, as it says, are open to anybody. You don't have to be a member for it. So there's our innovation conference, which I'll mention again later, and that Unlocking Innovation event on Whole Systems in May, and our annual conference later in the year. And if you click on that, then you'll be asked to register on the website. That's not making you a RIA member, it's just registering on the website, and that when you do that, that allows you to sign up to what's called the innovation community, and that will allow you to keep in touch with all the things that are going on in Unlocking Innovation. So at that point, I would like to hand over to Emily to give you a practical example of what UI is all about. So Emily, over to you.
Thank you, David. Hi, everyone. Yeah, no, we're delighted to be invited to give you a case study about our entry into the rail industry and how we work with RIA and unlocking innovation to be able to access that. Hopefully, the sharp-eyed of you have noticed a lovely view of the Scottish coastline there on the case study, and that's just an example of some of the work that we've been doing. So next slide, please, David. Okay, so we're an SME. The four of us founded it originally in 2017, and our background was all about was in intelligent video, and we'd focused on the highways industry and sports broadcasting. And we had a lot of expertise under one roof, hardware and software. But during actually sort of in 2019, we were looking for other areas in which we could deploy our intelligent video capability. David, next slide, please. Oh, thank you. Yeah, so in 2019, as I say, we're exploring further opportunities for our video expertise, and we did quite a bit of sort of industry exploration, emergency services, local authorities, etc., and the rail environment. And we attended Rail Live event, which was a sort of an industry event that had a lot of things being demonstrated. And one of the things we heard with Network Rail was their aspiration for to work with innovators in the SME supply chain. And that really gave us quite a lot of confidence to explore our capabilities in the rail environment, which led to us developing our AVA product. We learned a lot about the industry through industry events and press. That was really key to us, that initial learning and engagement. And some of the sort of the accessible events that David mentioned there was what we started to attending before we really focused on kind of membership and growth from there. Our focus was about harnessing the coverage of in-service trains and making video data rapidly accessible. So that led to us spending a bit of time developing our own proof of concept, understanding about the challenges and objectives of the rail industry, learning TLAs, which those who don't know are the three-letter acronyms, which seem to cover everything in the rail environment, and you have to Google quite a lot to check you're talking about the right thing. And the really important thing was that as a software and technology provider, we were able to rapidly respond to requirements, iterate, and we worked really closely with people that we started meeting to understand what their needs were. Just those images are kind of our testing. We used to hold our smartphones in the windows of passenger trains as we travelled around trying to identify things line side. We hired a trial train at Quinton test centre to be able to get out and about and test it in the rail environment before going anywhere live, and did a lot of theoretical based developments at our offices. So that's kind of where we got to, sort of as new entrants into the rail industry, really understanding where there were the challenges and what we could do. Next slide, please, David. Then we developed our product, and this is just a brief touch on kind of basically it was about bringing intelligent video into the rail environment, enabling people to see what they needed to see. And there was a massive demand for this as the impact of COVID really started being felt across the country and across the industry. How could they see what they needed to see? But more importantly, for this occasion, David, next slide. It was about how we kind of developed that industry engagement. And as David said, it was kind of an entry-level capability into the RIA events, like attending as sort of members of the public rather than members, gave us the ability to start to get the feel of the environment, the feel of that innovation and energy, and that was really crucial to us. And then what came from that was the ability to network, to demonstrate the product as we grew. We had things that we could share and that we could feature. Very importantly, the ability to pitch as well. You've got to evangelize to the extreme and to the point where you feel like you're boring everyone to death about the thing that you're trying to promote. But that platform to enable that to do that was really crucial. And as that's developed and as what we've grown as AVA has developed, we've been able to then kind of contribute back into that conversation as well, hopefully a little bit about what we're doing here today, saying, it is possible. There are certainly challenges around it, but yeah, the door is open for innovation and for hearing from new suppliers as well. Very much what people call the rail family as well. So a lot of people seem to know everyone within the rail family, but they're also very welcoming of new members and new friends and colleagues. A lot of the RIA and the UI series helped us to understand the positioning within the industry, what the real objectives were, net zero, the digital railway, the remote condition monitoring. Ultimately, what we do is try and increase safety across the rail environment by removing the need to go to site and attend that. So as I say, yeah, we now provide kind of an SME perspective in that. Hopefully, we're sort of a success story. We started in rail about 18 months ago and have developed our product really closely with the rail needs, but also by bringing new methods and new technology into that. So everyone that we've met along the journey has kind of been keen to understand how things can be done differently, what insight they can get from other environments where things have been tested and trialed before. So yeah, that leads to like really positive developments, but also there are a few challenges along the way. There's some images there, sort of, as David said, the energy of being at events and networking, getting to know people and meeting them again, and also kind of developing relationships along the way. Where we, I can't see the date of that, my screens, but in June, yeah, so we contributed to another online UI event where, again, we kind of talked about our digital railway capability. We were finalists in the RIA Rise Awards for SME growth in rail. So it's it's an opportunity to recognise the. I don't know who won it. They must have been extraordinary to beat us in the final, but we'll try again next year. But the ability to be able to access that platform and showcase what the fantastic achievements that the SME supply chain can be delivering, and also Network Rail have used us now as a case study as how innovations have been brought into the industry and have been really shaped to meet the challenges that they're facing. So that's kind of a quick snapshot of how we came from nowhere. As I say, no rail knowledge prior to that. We met the likes of RIA, David and his team, who kind of have helped champion and engage in what we do. And yeah, we sort of stand. We've got contracts with Network Rail and just signed a 3-year contract with Transport for Wales. So we're really becoming an established part of the supply chain. So I would encourage any of you to take advantage of those routes as well.
Thank you very much, Emily. Emily and One Big Circle are a great example of how you can grow in the rail industry quite quickly, but they're by no means the only one. We've got quite a number of success stories through unlocking innovation. So moving on now, just to sort of conclude. Yep. We've been talking about the Unlocking Innovation scheme. Just to give you the bigger picture, so that the Unlocking Innovation scheme is our one of our open to all activities for anybody to join, but there has to be a reason why you might want to be a member, and over the next couple of slides I'm just going to touch on that. So we've been around quite a while, and maybe not quite as long as Scottish Engineering, but we're over 145 years old, got about 320 members, and a big chunk of the established suppliers in the industry. And we do all those things on the right-hand side, which are things that many trade associations would do. But I've tried on the next slide to give a bit of a flavour of the breadth of things. So if you think about the triangle or an iceberg here, then there's things that any of you can access, as Emily did when she was coming into the rail industry. The Unlocking Innovation and our exports activities are open to everybody. You don't need to be a member. But if you do want to become a member, then you get access to all the other things in the triangle here. So we have a dedicated SME group. We give access to the top clients and funders. Coincidentally, Emily was talking to a minister the other day in a round table that we had. Now, we've talked about the Unlocking Innovation events. Those really are the tip of the iceberg. We run a ridiculous number of events every year, which are part of the membership deal. No extra cost to those. Total of 70 events, roughly, across 16 technical and special interest groups. We campaign on behalf of the whole industry for things like avoiding boom and bust, decarbonisation, digitalisation, equality, diversity, exports, wider economic benefits, etc. And all of that's underpinned by a team of expert professionals, if I can include myself in that, perhaps, I don't know, but certainly my colleagues are expert professionals. So you get access to a lot of resources. The last thing I think I want to mention is, and this is open to all, but I'm afraid there's a cost to it. But it is going to be a really good conference at the end of April. It will be virtual, but it'll have high-profile speakers. In fact, on the next slide, this isn't the most brilliant slide, but it's got people like Andrew Haynes, for example, the rail minister opening it up, and a whole range of speakers within those panels. If you look on our website, you'll see more details. And that sort of brings us to, we've trotted through that at a fair old pace. So I'm hoping that's given you some questions that you'd like to ask. I'll unshare my screen, but I'm very happy to take any questions, and I'm sure Emily would be too.
I don't think we've got any questions so far, unless I'm missing something in the chat, but I don't think so at this stage.
Okay.
Maybe people will have a think about it and ask it. Sometimes it's quite hard when you've just heard something to answer, ask something straight away. So we'll maybe just move on to Roger Moore now. And if you do have a question from this section, please feel free to post it, and we'll get back to you at the end of Roger's section too. Thank you very much, David and Emily. That was really, really very interesting. So thank you.
Thank you. Thank you very much.
Good afternoon, everybody. Just share my screen. Okay. I'm Roger Moore. I'm from Network Rail, and I manage the product acceptance process for the company. I'll be running you through this presentation, which gives you a brief overview of the process and who's involved with the process and what sort of assets we look at when we're approving items. So what is product acceptance? Well, product acceptance is an assurance process that was initiated in the late 90s so that we as a business can make sure that safety critical products used on the operational infrastructure are safe, fit for purpose, reliable, compatible, do not export unacceptable risk on our infrastructure or to the users of the infrastructure, and also to make sure that items align to both our technical and commercial strategies and also Network Rail's challenge statements. So Network Rail's challenge statements have been created to support our technical strategy and the railway's future vision as set out in our rail technical strategy. Each statement details specific business obstacles and provides details on the definition, root cause analysis, priority areas of focus, and also they outline what we're looking for. And these can all be found on the Network Rail corporate website. If you type in challenge statements or you just Google Network Rail challenge statements, you'll find them. And they're broken down into various technical areas. And hopefully, if you look at that, you can look at those, you can see out of the list of somewhere around 50 of them where your products probably fit into our challenges. There's also a link within there. So if you've got a new innovation, you can send in your idea to the R&D team so they can have a look at it. So who are we? Well, I've got a small team that's centrally based within the research and development function of Network Rail's Technical Authority Directorate. And we manage two product acceptance processes, kind of what we call product acceptance standard, which looks at typically single items, and also system review panel, which, as it says on the tin, sort of looks at systems, but it also looks at more complicated innovations where multiple asset areas need to look at the items. So for instance, you might have something that is a plant asset, but there may be requirement for our track team to look at it to make sure that if you put it out on the track, it's not going to damage their track. And other asset areas typically that look at items are, for instance, EMC, ergonomics, you know, because it might be nice having a piece of equipment that you take out on track, but it needs to be reviewed to, you know, establish how heavy it is, how many people need to lift it about, how you can transport it to site, all these sort of issues. Our day-to-day activities include reviewing all the incoming applications we get for acceptance. Stakeholder liaison, as you'll see shortly, there's quite a few stakeholders involved in the end-to-end process. The issuing and an endorsement of certification. So at the end of the process, you'll gain certification to show that you've, you know, successfully been approved by the product acceptance process. Monitoring and reporting of PA output and performance, and also management of continuous improvement initiatives. So what do we approve? Well, we have a standard, and the reference number is on the top left of your screen there. And as I said before, it's all items that are deemed safety critical that are used on the operational infrastructure. And they fall within the categories at the bottom of your screen there. So electrification, signalling, plant, telecoms, tracks, switches and crossings, level crossings. And they can be all manner of assets, whether it be componentry that makes up the track, or the formation of the track, electrification components, whether it be overhead line or third, fourth rail systems, telecommunications assets, signalling systems, and as I mentioned before, plant. So what do we not approve? Well, we don't approve items that we deem as low risk. So items such as PPE and boundary fencing don't come from through our process. We don't approve rolling stock because Network Rail doesn't really own any rolling stock apart from our yellow measurement train. Civils assets don't come through our process because Network Rail has a separate civils design process and associated standards. So anything deemed civils to do with bridges and, you know, all of the sort of civils assets will go through that process instead of ours. We don't get involved with supplier accreditation because there's an industry supplier accreditation scheme called Risks, which is managed by the RSSB. And we also don't approve most assets within the station forecourt environment because they're not typically items that are linked to the operational infrastructure. So all of your customer help screens and information points, escalators and lifts, all those kind of items don't come through our process. The only scenario that falls outside that is for what we call category 12 subsurface stations. So for instance, Birmingham New Street or St Pancras. And that's because there's additional fire safety risk associated with those areas. So to get an idea of the items that do require acceptance or don't require acceptance, we've also got a guidance document which lists the majority of categories of items that we look at. You can find this via the Network Rail corporate website. If you go into the corporate website and type product acceptance, you'll find a lot of information relating to our process. And one of the guidance notes is this document, which is called How to Decide What Needs Product Acceptance. We categorise items in three ways. We either call them controlled, which means they definitely need product acceptance. uncontrolled, which means they don't need product acceptance. And there's a third category called controlled limited criticality. And these are for assets which are typically off the shelf, and there's no railway specific technical requirements associated with these. So, you know, all we're asking for is evidence that they meet BS, whatever, those kind of national standards. It's quite a long list, and it's broken down into the different asset areas such as signalling and electrification. And it also gives you an idea of what other asset areas need to look at the items. So as you see on the list at the top, it lists all of the other possible asset areas that could look at a certain item. You can see there you've got line side cabling, which is signalling, but also EMC need to look at it. And it also requires design for reliability, DFR. And Kevin will talk to you about that shortly. So who else is involved in the process? As I said before, there's numerous stakeholders. The main ones are listed here, and the main one overall is our engineering teams within the technical authority. They're basically responsible for undertaking the engineering assessment for all of the items that come into us. So the items will come into my team, and then depending on what they are, they'll go to the relevant engineering asset area, who'll sign a lead reviewing engineer to the item, who will then assess it and then provide whatever technical requirements need to be met prior to the acceptance of that item. We have route services category management. They look at the commercial side. So when items come into us, they review any commercial data that's come in, and they may intervene if, say, we have a framework contract in place for certain assets, which means that we can't bring in additional suppliers at that time while the contract's running. They might also look at the items and question unit cost data. You know, why is this twice the price of anybody else's asset that we're buying in this area? Or they might, you know, query why we need a 20th variant of something that we've already got 19 approved of. So as I say, they look at all the commercial side. We have route services, supply quality assurance. They tend to only look at new manufacturers that come in to decide whether they need to go out and audit the manufacturing facility. We have route services catalogue management. At the end of the process, all the items that are approved will be provided with catalogue numbers, and they'll go into the Network Rail iStore system so that Network Rail people can purchase them. And they'll also go into the industry PASNet system so that the wider industry can see that the items have been approved. And as I said, that's all the numbers are allocated at the end of our process. And we've got design for reliability, but as I said before, Kevin's going to talk to you about that, so I'm not going to discuss that at this point. So requirements before entering product acceptance. Well, first and foremost, items need to fall within the scope of our standard. If they don't, there's a good chance that they don't need approval. Or they could be assets that we've never seen before and don't fall within our kind of long list that I just showed you. So with those kind of assets, they need to be looked at on a case-by-case basis by the relevant engineering team to determine the criticality of the item and whether or not they need acceptance. And because there's a lot of new innovations that have come to us in the last few years, we get more and more of those sort of assets that need that kind of initial review by a technical expert. If it does need approval, we need to make sure that it is actually ready for approval. And we do this by utilising a mechanism called the Rail Industry Readiness levels. and you'll see at the bottom of the page there kind of top line overview of how they work. And the majority of them are associated with the product development life cycle. So all the work that needs to be undertaken, before an item is fully fit and functional and ready for deployment on the operational infrastructure. Where we sit is kind of after RIRL 5, so sort of near the end of the orange portion of the diagram below. So once all of the R&D activity has been achieved, and this matrix you can find again within our guidance material, and it will give a complete list of all of the requirements under each readiness level within that. It's pretty hard to show on a screen like this, because we found it's pretty impossible to read once you try to present it. But if you go in there, there's all the detail associated with the individual requirements. And for product acceptance, the lines that we're interested in are what we call technology readiness level and reliability readiness level. And you'll see those individually listed in there. And all items that come to us need to be applied for or on behalf of a suitable Network Rail employee, who we call the applicant. And basically that's somebody who acts in the sponsorship capacity and can demonstrate a business need for the product or the change to the product. And that, as I said, is to make sure that when items come to us and they get approved, that somebody's actually there that's demonstrating a requirement for them and is going to use them and purchase them. The only items that fall outside that scenario are plant assets, and that's because Network Rail doesn't really buy plant items. They're typically bought by our contracting organisations, and because of that, we decided to implement a scheme so that the plant assets can be assessed externally by organisations called plant assessment bodies, PABs. So now all of the plant assets go to the plant assessment bodies for an assessment instead of our internal engineering team. At the end of that process, the PAB will come to our network technical head and prove that they've met the relevant technical requirements, and that technical head will then endorse the certificate. The process itself is fairly simple. It's broken down into 4 categories: got application, assessment, operational trial if required, and certification, so the full certification. So the item will come into us. My team will undertake an initial assessment, as I said before, to make sure that the item requires acceptance, and if it requires acceptance, is ready to be assessed. We'll then provide some initial requirements up front. So, for example, we'll be looking at details of the configuration that make up that item, evidence that the company's got ISI accreditation, ISI 9001 accreditation or equivalent, details of things like CE marking. So we'll ask for that up front. The item will then go to the relevant technical team. Will assign the lead reviewer, set the technical requirements, and then obtain that evidence back via the sponsoring applicant from the manufacturer. When that evidence has been assessed and it's been deemed that it meets the requirements, then the engineer will decide whether or not the item needs to be trialled on the operational infrastructure. If it does, a trial certificate will be provided, and that will include trial requirements that need to be met before the item is fully approved. If all of that's okay, then the item will be provided with a full certificate. And that's the end of that process. So it's fairly simple. But where typically items get stuck is trying to obtain the evidence back from the manufacturer. Sometimes that can take a long time because, you know, evidence needs to be gathered from, say, you know, the parent organisation abroad or something like that. This gives you an idea of product acceptance certificate that's provided either for trial or full approval. Throughout the document, there's a lot of information that's detailed within it, including conditions of usage, general terms and condition, details of the configuration that make up the item, and all of the catalogue numbers that are assigned to each of those items. And the front page here will tell you what the item is, the scope of acceptance, so how and where it can be used, and also who's endorsed it. It will always be somebody from within my team and the relevant network technical head. So a few statistics for you. We have more than 130,000 products accepted for use on the infrastructure. So, you know, we like to make sure that out of all those items that people are actually using them. Our catalogue team undertook an assessment a few years ago and found that there were quite a few items that hadn't been purchased and used, which is why we, you know, strengthened up our kind of sponsorship route into the process to make sure that, you know, we're not utilising a lot of engineering resource to assess items, put them in the catalogue, then nobody purchases them. We have somewhere in the region of 40 to 50 applications that we receive each period, which equates to around 500 to 600 per annum. Of those, it's a rough split 50-50 between new items coming into us and what we call change requests. So change requests can be where an item's already approved, but the manufacturer wants to upgrade the item, change the item. But it can also be for scenarios such as the item's only been approved for use in a certain sort of scenario or a geographic area, and other people want to use them in a different area. Or, for instance, something might be approved for use only in OLE areas, and somebody wants them approved for use in third or fourth rail areas. So there's various scenarios of why we would need something to come into us as a change request. We reject approximately 20% of applications that come into us, and they're always for the same reasons. Either they don't need acceptance or they're not yet ready for acceptance. If they're not ready for acceptance, it could be also, and Kevin will take you through this in a bit, that there's a requirement for design for reliability to be undertaken before they come to us, because a lot of the reliability requirements are required, you know, throughout the research and development phases of the rail industry readiness levels. So, you know, we may reject that, but we've also recently adopted a new mechanism to bring items in early that need DFR, so that we can allocate a number to them and give our engineers sight of them before design for reliability has been undertaken. We approve probably around the same amount of items each period that we get come in. So between 40 and 50 items are approved every period. And we have somewhere in the region of 100 trials underway at any one time on the operational infrastructure. This is something that we're looking to reduce because there's more of an emphasis on making sure that we try to trial items off the operational infrastructure where possible. So we've got, for instance, various test facilities around the country that can be utilised to assess items, or maybe heritage railway sites or sidings and all these kind of areas. And also laboratories, you know, if we can gather information that meets certain technical requirements by laboratory testing, then we'd prefer to get that evidence rather than put them out on the live infrastructure. So a few key product acceptance achievements and objectives. There's been a significant focus on our work bank to make sure that we're providing an efficient service, and also to make sure that, you know, we've not got too many in there, so we're bombarding our engineers with far too many at any one time. Years ago, there was somewhere in the region of 700 items live in the system. At the moment, there's 68 live in the system, which is far more manageable and a reasonable amount to have in there. We've also, because we've undertaken an assessment of all those and driven all of the older items through the system and out again, there's been a steady decrease in the turnaround times of applications that we get. So 85% of requests now reaching their first certification, whether it be a trial or full certificate, within 40 working days of receipt. And we had a target from the Secretary of State, which was 80%. So we've beaten that. As I mentioned before, there was a pilot exercise to outsource plant applications to the PABs, and this was successful and is now business as usual. There's also been a steady increase in focus on stakeholder engagement. So hence the reason why I'm speaking to you today. We undertake a lot of internal and external surgeries and briefings around the country to make sure that, you know, all the stakeholders are familiar with our process and what's required, particularly internally with our sponsoring applicants, because obviously there's, you know, a lot of activity around the sponsoring of an item, whether it's by acting as the sort of middleman between our engineer and the manufacturer, or liaison with the routes for the trialing of items, because, you know, you can't just put an item out on the live infrastructure. You might need to, you know, get into a work site within a possession so that you can actually test in the live working environment, or, you know, within a work site with people, you know, physically able to sort of run things over it or hit it with hammers or whatever. There's a provision of more guidance material on our corporate website and our internal web space. As I said before, if you go into the corporate website, there's all manner of guidance material, and also our application form on there. So, you know, if you've got an item that needs to come into our process, then the application form resides within that web space also. We've also been working with other industry bodies to try to establish whether there's best practice or cross-acceptance opportunities. This gives you an idea of our work bank split between the different asset areas. As you'll see on here, 36% of the items that we get in, which is, you know, by far the biggest portion, are for electrification distribution assets. So that's, you know, typically all of the big sort of electrification switchgear systems. And then, you know, the next there is telecoms. We get quite a lot of telecoms assets, followed at the moment by track, and all the others is a fairly small number. This gives you an idea of over the last 12 months, what's happened to the last 531 applications that we've received. 68 of those have had certificates issued. 13% of those have been cancelled because they either didn't meet technical requirements, or it was decided after an level of assessment that they was no longer required. 12% of those are live applications, and as I mentioned before, we also have a number of what we call DFR inquiries for design for reliability, and 7% of those are for that. And a few tips before applying for product acceptance. As I said before, there's a lot of guidance material, so please make sure that you read as much as that as possible, because it gives you a lot more in-depth overview of what is required and who's involved. Provide the response to any technical requirements or trial requirements as soon as possible. As I said before, typically items get held up waiting for evidence to come in against technical requirements. So the sooner that our engineers receive that evidence, the sooner they can assess them and provide approval. And also contact us in the first instance if you have any queries or encounter any issues with an item you've got going through the process. You know, we'd sooner hear that there's an issue with something sooner than later, so that we can intervene and, you know, find out what's going on. So I think that's about it for me.
Thanks, Roger. That was great. I've got a couple of questions for you, if that's okay.
Yep.
So John Campbell asks, how does an SME who is perhaps one or two tiers down the supply chain interact with product assurance for in-scope products?
To find out whether or not something's within scope, as I say, we have that long list, that big guidance note. So, you know, first port of call is probably to have a look at that. And our email address is all over the place within our documentation as well. So you can always email us if the item's not on the list. You know, because as I said before, we've probably new innovations that we're not seeing before. So we'll need that sort of heads up by the relevant technical team to look at it.
Brilliant. This is one from me. A wee cheeky question for me. Does the first tier contractor have to seek approval on behalf of the SME, or does the SME seek approval?
Whoever owns the asset is the person that, you know,
Right.
we deem as the manufacturer throughout the process. So, you know, if you're someone that has made a generator, for instance, then, you know, whoever that company is will be who we deem as the manufacturer.
Right. Okay. Great stuff. And John Campbell also asks, what is the cost? Is there a cost affiliated with this going through this process?
Not unless you're a plant asset, because the PABs are external organisations, and if you go to them, then, you know, you'll set up a contract with them, and they'll provide timescales and, you know, scope.
Okay.
But for everyday assets, it's internal product acceptance is basically funded by our routes, so there's no associated cost with that, unless, you know, the routes may want to intervene and you know, charge for for going into, you know, possession or something like that. It's not something I've heard of, but
okay, great. Okay, so just as a quick question for everybody listening, if you could just type in the questions there, what TRL stands for, RRL stands for, and PAB stands for. I'm just kidding. It was just to check you were listening, because there's an awful lot of acronyms in the rail sector. So if you do get them, though, I will send you a prize, so you can think about it over your tea and coffee break.
Fortunately, one of our guidance documents has a whole list of acronyms. And
Brilliant, brilliant. So we've just reached about 3 o'clock, which is perfect timing. And what we're intending to do now is just have a quick 10 minutes to allow you to go for a coffee break or stretch your legs. And we'll be back at 3:10. I'm going to leave the link on. I'll mute it and I'll leave the screen on. But come back at 3:10 and we'll hear about the design for reliability process. Thanks so much, Roger. That was packed full of detail. So thanks very much. And we'll see you at 3:10.
container.
Hi, Kevin.
Hi, Shona.
I think we're just about 10 past.
We are now.
We'll just give people a little second to get themselves sitting comfortably. Okie doke. Welcome back, everybody. It's 3:10, and we're going to kick off this final part of our session with Kevin speaking about the design for reliability process. So thanks very much, Kevin. Over to you.
Lovely, thanks. So yeah, so design for reliability, basically what is it? It's a move away from how we used to do product acceptance that Roger was talking about just now, where we used to really focus upon the legality and the safety of products that we were approving for use on the railway. And we didn't tend to look at the reliability of them so much back then. Any focus on reliability tended to be, if we installed them and they failed, trying to get them up and running afterwards. And the idea with design for reliability is about being much more proactive. It's about seeking evidence from suppliers of new or changed products to show that we can have confidence in the fact that they are going to be reliable when we approve them for use on the railway. So that's really at a very high level what it's about. And I sometimes get people say to me, if you could go back in time to when design for reliability was being created, is there anything you do differently? Is there anything you change? And there is. The thing I do is I wouldn't call it design for reliability. I'd call it design for availability. And availability is a little bit subtly different to reliability. Whereas reliability is how long something might take before it fails, availability is the ability of us to operate the railway. The fact that when we need it to be there to allow a train to move from A to B, that everything's working and that it can do that. And the reason why, if I was starting from scratch, I call it design for availability, is the fact that supposing I got this product, yeah, so it's a teacup there, but pretend that's a railway product. And supposing that this had got a mean time between failure of 30 years, but sometimes it lasted as long as 40 years and other times it lasted as little as 20, but on average it lasts 30 years. So that's the reliability of it. But now I've got this other product, this mug, and this one on average isn't as reliable. This one's got a mean time between failure of 28 years rather than 38 years, so it's less reliable. But with this one, supposing it always fails on its 28th birthday, so less reliable, but I'd rather have that one. The reason I'd rather have that one is because if I know when it's going to fail and there's less variability in it, I can schedule somebody to go in there a week or 2 weeks before it fails, do some maintenance activity to replace it, or to bring it back up to speed again to where it needs to be in terms of its performance and so on, and deal with it that way. Also, maybe I could build redundancy into a system so that even though these have got inherent unreliabilities in them, by putting them both there so that if one fails, the other one kicks in, I can get great availability even with some lack of reliability in there. So availability is much, much more important than reliability. But of course, one of the best ways of achieving availability is by making products within the system more reliable. So one of the things I've done is I've added a slide beyond what I normally have in the DFR materials here, because I'm very aware this is all about suppliers engaging in the railway. How can they start to work with Network Rail and so on? So I've added this slide here, and it links back to something that Roger mentioned in his slot just now about the fact that any new or changed products coming onto the railway need one of these applicant sponsors, somebody at Network Rail who says, yeah, we do actually want this for the railway. And so clearly one of the things you need to do is to find somebody within Network Rail who's going to act as a sponsor. So how might you actually go about doing that? And Roger mentioned something called challenge statements. These things that we've put out there, a list of products that we'd like to see on the railway or solutions to things. So I put the link on there that Roger mentioned about on this slide, and also an email address that you can send to if you can solve one of those. Yeah.
So, I'm really sorry to interrupt. Are you showing slides?
Slide, can you?
Because we can't see slides, no.
Great. Yeah. Okay.
Sorry.
No, thank you. Thank you for butting in and saying that. Brilliant. There we go. Hopefully you can see it now. You see it now, Shona? Brilliant, fantastic.
Perfect, thank you.
Okay. And that back up again. Okay, so that's the link to the challenge statements. Also, as we've seen from the discussion from David, there's rail industry associations out there that can help. Also, we have some people called we have some people called small medium enterprise champions within Network Rail. And we have one for Scotland. That's the email address for the person for Scotland there. We have them for other parts of the country as well. But because this presentation was Scottish focused, I put that on there. Happy to let anybody have the other names if they're interested. Also, if it's not a small to medium enterprise that we're dealing with, there's another link there, which has got a list of different categories of items that we use on the railway, and has got some contact names in there for that. But of course, if you're already supplying Network Rail with something and it's a product that you want to change for reasons that the supplier wants to change it, maybe they found a way of making it cheaper or making it compliant with new standards that come out and so on, then typically if they're already working with Network Rail, they'll already have a contractor rep assigned to them, which is part of the procurement process we go through. But if it doesn't fall into any of those items that I've just mentioned there, we also have the link at the bottom there, which is a page on the Network Rail site that you can go to just for making general inquiries. So maybe there's something that isn't listed on the challenge statements, but you think, that's just because Network Rail haven't realised that that's something that would be possible to do. So if it doesn't fall into any of those other things, that's another way of getting in contact with Network Rail as well. Right, so I'm going to move on from that slide now and get back into the stuff about DFR specifically. So I think rather than just describing what we expect from design for reliability, I think it's important to understand why it was that we introduced it. So this graph here, this starts off back in the year 2000, and it shows the level of train delay that was happening on the railway that Network Rail were responsible for. So back in the year 2000, it was around about 8 million delay minutes per year. Probably a bit tricky to get your head around that. That's about 10 trains stood still at any given point in time, which I think is much easier to sort of get your head around and realise the impact of that. We then had the incident at Hatfield, and because lots of speed restrictions being put on the railway and so on, that went up to just over 20 million delay minutes. And since then, it's come down, not necessarily smoothly, but it's come down to where it was at the time we introduced design for reliability, which was around about 8 million delay minutes once again. So it's showing that we'd not got through that barrier. We were still at that 8 million delay minutes, and we wanted to find some new way of doing things, because clearly just trying to work harder at these things wasn't achieving it. We needed to do something different to get into that space between below 8 million delay minutes. And so that was design for reliability. This graph's a little bit unfair because, of course, even though it shows us staying still in terms of the number of delay minutes, we had a lot more trains on the network in 2016, 2017 than we did back in the year 2000. So actually staying flat there does show some level of improvement. But when you look at those 8 million delay minutes, the sort of things you see in there are issues due to not designing reliability in the first place, where a supplier had come to us and said, we've got this great new product. It's so much better than what you've got before, and we'd approve it, put it onto the railway and find we get teething issues with it. So that's what we really wanted to tackle with design for reliability. But I don't want to give you the impression that this is purely about issues with the design of the products that's inherent in that. Also, there's other things. For instance, on the railway, as opposed to, say, the automotive industry or the aerospace industry, we do an awful lot of installing products. So we fit products onto the railway, and that gives another opportunity for doing things wrong when we install something. And a good example of this is the fact that if you look at switches and crossings that are fitted onto the railway, so point machines for deciding what route a train is going to take, in the first year after they're fitted, they're typically twice as unreliable as they are over the rest of their life. And of course, it's the same product. We haven't changed the product. It's because we're dealing with those teething issues on the product due to the way we install it. And you'll see that that forms part of the DFR process as well. And also, when you look into those 8 million delay minutes, it's amazing how many times it's the same sort of causes coming up time and time again. Things like temperature, not just high temperature or low temperature, can be sudden changes in temperature. Things like poor connections of cables, electromagnetic compatibility, where something's affected by an electrical component near it, and of course, water ingress as well. And I remember about 3 years ago with water ingress, we get these things that get sent around within Network Rail called notice boards. It's like a single page of PowerPoint where somebody in one part of the business has seen something and they want to tell everyone else so they can avoid suffering from the same problem. And within 4 weeks, there were 3 related to water ingress on totally different products. One was a product that was down near the ground, and it got a drain hole on the bottom in case any water got into it so it could drain out. And there was some localized flooding and the water came in through the hole. Another one was a product that was up on a gantry, and that one, the casing didn't quite come together properly and water came in from the top. And the third one was the weirdest one. The third one was a housing for some electrical components, and it got a vent hole on the side so it could let any water vapor out. And of course, having electrical components inside meant it was warmer than the outside air. And we had a situation where a large insect decided that it wanted to make its home inside this casing because it was warm, started climbing through the hole to get in, got halfway in and then died. And its body acted as a wick and drew moisture and water in from the outside. So time and time again, it might be the same thing, water ingress, but it manifests itself so many times into different products. So this is something we wanted to build into the process, learning from past history. As I said, previously, before DFR, a lot of our focus on reliability was about fixing things afterwards. And I was part of the reliability team within Network Rail that did that. And so when designing Design for Reliability, we all sat down together and we said, what are the things that are stopping us getting better? What are the things that are stopping us from designing reliability in? And we came up with 10 things, and these 10 things form the basis of the DFR process I'm going to show you. So the first one was that there wasn't any expectation, training or support for tried and tested methods that have been used in other industries like automotive and the aerospace industry for decades, but these just hadn't made their way onto the railway. And it wasn't just Network Rail, it was the railway as a whole these hadn't made their way onto. So we did have a guidance document, but it wasn't mandatory. It was just a suggestion of some things that suppliers might do to make their products more reliable, but it had never been mandated in the way it is now by Design for Reliability. Clear requirements. There's it was a 3-day, full-day classroom course on Design for Reliability that we've run 35 times. It's 5 half-days now because of COVID. But during those courses, when we ran the very early ones, what we kept hearing time and time again from suppliers was that the challenge for them in terms of making a product that could reliably deliver what Network Rail wanted was a lack of clarity on requirements. They really wanted to know right at the very beginning, what is it that you want from this product? So you'll see in the process, some of the early steps in the process are all about Network Rail being very, very clear exactly what they want from that product. It's a loop there as well. So Network Rail saying what they want from the product, the supplier saying how are they going to deliver it, and Network Rail saying, yeah, you've understood that. You've understood the requirement that we're after. As I mentioned, learning transfer, sharing all this history that we've got on products that might have failed on the railway in the past. Clearly, we've been collecting information on this for a long, long time. And historically, when suppliers have designed new products for us, they've done that in total isolation from that information, even though we've got all of that useful information. So now our process allows for sharing of that information with suppliers to say, you're going to design one of these products. We have one similar, and on that one, these are the things that we saw happening on it that caused the failures, so it can be designed better. Well, the next one's all about how we test things. Several times in the past, I've been to visit suppliers. Sometimes we get supplier quality assurance going in to visit suppliers to see how they're operating and so on. I've sometimes been with them on some of those visits to suppliers. And I know on a few occasions I've been met at the gate into the facility, the supplier's facility, by somebody who's looked really excited, really keen to show us some things that they're doing. And typically we'll go into the supplier's premises. They'll take me into what typically is something like a warehouse, take me into the corner of the warehouse, and there will be their product. And the supplier will say something along the lines of, here's our product. It's been going up and down or round and round or whatever it is that it does when it cycles, 1,000,000 times, and it's never failed once. This is how reliable it's going to be. But the trouble is, I look above my head. What do I see? I see a ceiling. So this is something that's designed to work outside on the railway, but they're testing it indoors and they're not throwing any water over it. Also, when I arrived, maybe it was snowing outside, but I've taken my coat off now because it's nicely heated. I've got air conditioning in there and so on, and no one's heating and cooling the product. And the product was probably built by the people who designed it as well. So they know what's really important to get right when they install it and when they fit it. Whereas when we put it onto the railway, we've got our people working at Network Rail all the way from Penzance down in Cornwall up to, say, Wick up in the north of Scotland. And those people could do things subtly different when they're installing it. So it's not surprising when we test things under ideal, perfect conditions like that, that we say, yay, everything's going to be fine. Release it onto the railway and then we find that it fails. So it's really important that we test things under much more realistic conditions. Avoiding manufacturing errors. We still sometimes see things where somebody's manufactured something and it's possible to fit something the wrong way round, for instance, or fit it in the wrong orientation. So thinking about ever-proofing that and designing that out is really key. I've spoken about installation processes already. And then we get to measurement equipment. When we design and manufacture a product, there will be very important aspects of it that we need to get right. And with those aspects, they're typically the things that we would measure. And something that we've typically done in the past with measurement kits, so something like this, is we'll calibrate it, won't we? So somebody will take this gauge and they'll take something, and if it's a vernier gauge, something like that, it might be a 5 centimetre block that's traceable back to national standards, the international meter, say. They measure it, and the dial says 5.00001. So we say, yay, fantastic. That's calibrated. Somebody signs it. They put the date that it next needs to be calibrated onto it. And we then think that's fine to go and measure whatever we want with that device. But the trouble is, the way we use this and what we measure with it can alter our ability for this to give us the right result. Because maybe I'm right-handed, so I hold it that way. Somebody else is left-handed and hold it like that. Maybe they get a different result. Maybe myself, because I'm not measuring something that's got perfectly flat sides. Maybe when I locate it on the thing that I measure, I put it in a slightly different position. So we expect people to go beyond calibration now, and we expect them to do something called a gauge repeatability and reproducibility study. Well, that's about taking 10 of whatever the object is that they want to supply to the railway, taking their measurement equipment and measuring all 10 and getting a figure for that. But then they measure them twice more. So they've measured them 3 times to see if they're getting consistent results when they're measuring it. But they don't stop there either. They then take that gauge and pass it to person 2, and they measure all those 10 products 3 times, and person 3, and they do the same. And that allows us to see whether this equipment is able to give us a consistent, correct result on these items when we measure them, which is really key. And I'd say that out of all of the steps in the design for reliability process, this is probably the one that gives the most benefit for the least amount of time and effort to do it. We actually run a gauge R&R study on the training course we do, where we have people conduct it. So it doesn't take that long. But I've seen so many examples of where people have put measurement equipment that they've got for manufacturing their product through a gauge R&R study and have found that it's failed. And as a result of that, they've changed their measurement system and improved it. So therefore, we've got much more confidence that we can sort out the not OK parts from the OK parts. Following well-written, easy to find instructions. I think it's a fairly clear one. System and interaction thinking. Realizing that when you design something for the railway, it doesn't just operate by itself. It has to work with all of the things that sit around it as well. So it might affect other things and other things might affect it. Finally, understanding causes before launching fixes. Because as Roger said, product acceptance and hence design for reliability don't just kick in when you design something brand new. It kicks in if you change a product. And sometimes we change a product because we're fixing an issue with it. And on too many occasions, we've seen where somebody has thought they fixed something, given us a whole lot of the new updated parts, we fitted them to the railway only to find it doesn't fix it. And we still get the issue after spending a lot of money on it. So it's really important, if the reason for a change is to fix something, that it's proven that somebody really knows what the cause or multiple contributory causes maybe of this issue are, and that whatever the fix is will actually solve it. So this is the solution, the DFR standard. So we're on version 5 at the moment. Version 1 came out on the 3rd of April 2017. So it's been around for about 4 years now. And as you'll see, it's quite a thick document, quite a meaty document. The reason for this is a lot of the information in here doesn't just tell you about what you need to do, it also tells you about what you don't need to do. So the document's been written to make it scalable. Because there are certain situations where you don't need to apply all the steps. And so there's a choice. I could have made this standard a whole lot thinner if it was just whenever you want PA for something, you have to apply all the steps. That would make this document a lot thinner, but it would make an awful lot more work for the people applying it. Whereas the alternative, the way that this has gone, is a thicker document, but it tells you when you don't need to do certain things, therefore there's less work involved. And I think most people would prefer it this way around, as it is. Yeah. So there's in that standard, there's a flow chart. And I know this looks a bit complicated, but all it is really is a series of yes/no questions. And those yes/no questions give you a code. And once you've got that code, it tells you which steps you do need to do and which ones you don't, because it relates to a particular part of the standard that tells you what you don't need to do. So taking it off the screen, simplifying it and showing you what those questions relate to on that diagram, these are the sorts of things that allow you to cut the process down. So if rather than introducing a brand new, totally innovative product, you're just changing the path through the process. The next one's really important. If it's a pre-existing design, if it's something that we call a COTS product, commercial or configurable off the shelf, this is one of the things that's been probably trickiest to get right about the DFR standard, where we want to use something at Network Rail that wasn't designed for us. Someone's been using it in the energy distribution industry, or very often it's something we use in telecoms that's been used in another industry. So it's not being designed specifically for us. All that design work's been done. So we have a very cut down path there for these sort of COTS products that already exist to say what we need and what we don't need. If it's a COTS measurement device, something that's off the shelf for measuring things, then again, that's cut down, because what we're really interested in is whether this can give us the right readings. And that starts off with just 17 of the steps, and very often some of those don't apply. If there's low reliability risk, so maybe we're making a change to a product and we've got a lot of confidence from prior changes that have been made that there's very low risk there, that can cut the product down. It's a really minor change. This came up when we went to version 2 of the Design for Reliability standard. Somebody came to me and they said that they were making a change to a product. And they said, it means I've got to apply all these steps. They said, this just seems too much. And they described what it was that they wanted to change, and they were quite right. All they wanted to do, they had a bolt and a nut, and they wanted to go from an imperial thread to a metric thread. So it's really, really simple. So as a result of that, we put another path through the process for these really simple changes that had little effect outside of the scope of that particular product itself. Now, that doesn't eliminate the whole of DFR, because clearly there's still things you can get wrong there, but it does focus in on just doing the key bits you need in those sorts of situations. If a supplier relocates, so if somebody moves their manufacturing process up the road, that starts off with just 11 of the steps that you need in that case. And again, some might not apply, because in that case, you're not redesigning the product. But when you move up the road, there's a chance that you might damage some of the manufacturing equipment, and that could affect the product. Or if you're taking measurements on the product, you could damage the measurement equipment when you're moving it. So it focuses on those things to do with how it's made. If you never believe you're going to make more than 9 of a product, again, that reduces some of the steps and changes the approach that we might take in certain cases as well. And the next one's really weird. The next one is where we don't have access to suppliers' data. Now, the reason we added this is because somebody raised something when we were putting together the very first version of the DFR standard. And what they said was, supposing that you've got some product where they're made in their millions by a company And Network Rail decide they want to use this on the railway, but we're only going to buy 100 of them. So we go to the supplier and we say, okay, we want to buy this, and we'd like you to apply design for reliability. And somebody said, well, supposing the supplier turns around and says, you've got to be kidding. We already sell millions of these. No, we're not interested in the business if we've got to go through that. So that was one view on it. But our supply quality assurance team said, we think that's unlikely to happen. We liaise with suppliers all the time, and we know that companies that are that large, that are producing things in those numbers, typically have a department, and we know who those people are that we tend to go to in that business, that will typically have the sorts of things you're looking for DFR anyway. So what we came up with is, because we didn't want people to have to raise deviations or derogations against the standard when cases like this cropped up, we wrote into the standard to say, if our supply quality assurance team have made a formal request to the supplier for the information and they've still come back and said no, then we have a cut down path through the process. And at this point in time, I'm not aware of any that so far have been given a PA certificate under that clause. So it's there if we need it, but it does seem that there's reluctance for anybody to be the first supplier that falls into that situation there. And the final one is a new one. As I said, the DFR course has been run 35 times now, and some of the people who started coming through were from companies where some of their colleagues had already been through the training, and they were saying that, oh yeah, this person went through, they came back, and we've modified our design process. We've built the DFR steps into it so that we always do them. So if that's the case, do we really need to supply the DFR evidence on a product by product basis every time we want to get PA? Can't you audit us so you can see that our process is in line with DFR? So that's exactly what we did. So we worked together with the network certification body, and suppliers can now pay them to have an audit. So it's self-funding, where they pay, somebody goes in and audits them, and if their process, the design process, complies with the DFR process, they get a certificate that lasts for 2 years that they can use in lieu of that evidence. Now, this isn't a shortcut, because the thing is that if you're doing it just for one product, you've only got to give the evidence for that product. If you're trying to get this certificate, you've got to show that you do this stuff consistently. So it's not an easy path, but if you're a supplier that's constantly seeking product acceptance from Network Rail for your products, it can be a much more efficient process. And therefore, we've had people go through and obtain that certificate. Now I'm going to show you the process itself. Yeah. And at the end, I'll show you how DFR interacts with the PA process, because I see somebody's just posted a question about that. I've got a summary slide at the end that shows that. So here we go. This is the process, and I've laid it out in a grid to try and make it easy to show on the screen. And the first thing that hopefully you'll notice is there are 3 environments you go through. The first is the virtual environment. So this is when you've got an idea for a product, you're thinking about designing it, but you haven't created a prototype yet. So all your information is on paper or on a CAD system or whatever. That's why it's called the virtual environment. Then we've got off-live infrastructure testing. So you've made a prototype, but it's not on the railway yet. And finally, you've got on-live infrastructure, where if we need one, we're doing a railway trial. Don't always need a railway trial, but sometimes we do. So 3 virtual environments, and those 3 virtual environments are split up down the left-hand side into 11 reliability readiness levels. So that's the answer to the question that Shona asked earlier about what does RRL stand for, reliability readiness levels. So there are 11 of these levels, and as you complete all the activities I'm going to show you on this slide, if you've completed the first row, you've achieved reliability readiness level 1. If you've achieved all the first 5, then you've achieved reliability readiness level 5, and that's how it works for seeing how far through the process you are. Along the bottom, you can see there's a bar that's coloured blue and yellow. Anything that goes above that bar where it's blue are steps that are done by Network Rail. Any of the things that go above where it's yellow, those are done by the supplier. And you can see underneath, it says impact level down here, 1, 2, and 3. And again, this is another way of scaling down the process. So impact level 1 is anything where if your product failed, it could potentially delay a train or could create a safety incident. That's an impact level 1. And as you can see, all those dots are filled in. It doesn't exclude anything. If it's an impact level 2, it couldn't delay a train or have a safety incident, but it could affect what maintenance you need to do. And you can see that there's some empty boxes there. or an empty box. That means you don't need to do anything above that. And also there's some non-filled circles. That's where the PA lead reviewer who's going to assess the evidence can agree that that step isn't required. And also it might not even affect maintainability either, which is that impact level 1 along the bottom. You can see a lot more of those unfilled circles where there's more flexibility for the reviewer and some more empty gaps on there. So you go across the first row, across the second row, across the third row, and so on. So there we go, there's the beginning of the process. These are the steps that are done by Network Rail. So it's all about specifying what we want. So the very first step is, what do we want in terms of reliability metrics? So it's Network Rail saying, this is the mean time between failure we want from this product. Also saying, this is the usable lifespan that we want from this product. And also, if it does fail, how quickly do we want it to be repaired? So the mean time to repair. That's the first step. The next step is saying what the duty cycle is we want. So how many hours a day is this thing going to be operating for? And also, what environment is it going to be operating in? So how hot is it got to deal with? How cold is it got to deal with? What sudden temperature changes? What amount of rainfall? So that's in there, not just for when it operates, but when we store it and when we transport it. The third step, green one there, that's that one about sharing historic failure data of where similar things have failed, sharing that with the supplier. And step 4 is bringing together all of the requirements that we've got for that product. So what are all of the requirements that we want from this? So it's very clear to the supplier what it is that Network Rail's after. The 5th step, shown in purple, might seem a little bit surprising to have this in a process associated with reliability, because it's all about cost. This is all about thinking about whole life cost, because the idea with design for reliability isn't just gold plating everything. Yeah, so things still need to be affordable for use on the railway. And a lot of work has gone on at Network Rail to move away from just thinking about the price tag on a product to thinking about how much it costs over its lifetime. Because it might be possible to buy something really, really cheap, but maybe the cost of spare parts for this are really expensive. Maybe the cost of maintaining it are really expensive. Maybe it's not particularly reliable, so that costs me a load as well. So it's all about thinking about the whole life cost of that particular product. So that 5th step there, that's where we state what types of cost will be included when assessing that product. And then at the end of the process here, or towards the end, you can see where we start putting numbers into that, so we can see what the overall whole life cost of that product is. Now this step here is where we move from Network Rail's world into the supplier's world. So this is the step where the supplier takes all of those requirements from Network Rail and they state how they are going to meet them. And if it's a totally new innovative product, we've got a tool that uses a matrix called quality function deployment. But if it's one of those off-the-shelf products, something that's already been used on another railway or from another industry, then the standard allows you something as simple as just taking the full list of requirements from Network Rail and writing down alongside it how that's actually achieved. So it might be a feature of the product or some form of testing that's conducted on it and so on. And as I say, that's where there's that checking back as well, that Network Rail are happy with the way that that's achieved. The yellow column you can see on there now, the first step in this is showing that there's an understanding of which bits of design for reliability are required. So it's taking the diagram I'm building up here and crossing out any of the bits that aren't needed. And then as you go down that column underneath, on the yellow there, it's about building up evidence showing that the tools within DFR have been applied. So what we have, we've got a standard template here to save every supplier having to do it individually. And what this has got, it's got the names of every step in the process and the title and the number of those. And it's also, as a thoughtful reminder there, against each of the steps in the process, it's got an example of some evidence. And that's the evidence that's used in the case study that we show on the DFR training course. So as you look through it, you think, okay, yeah, I've got to do that particular step there. Okay, yeah, this is how somebody's done it on another product. So you take that out, the example, you put your own evidence in there, so it helps remind you what it is exactly that Network Rail need. The brown column there, they're not mandatory, but those are the opportunity to remind people that if somebody has struggled with something as they've gone through that line on the diagram, that's the opportunity to get the team together to discuss it to overcome any issues there. The 3 black steps in the circle there, that's where the initial design gets put together now. And as well as putting the initial design together, it's about where we've got a supplier that's maybe supplied a whole lot of other similar products in the past. How do they store that knowledge of things that have worked well previously? Where have they got some sort of a good practice guide where they store that so they don't lose any good ideas they've had before? So for certain parts through the process, that's something we look for as well. And then we get to the real engine of what makes design for reliability work. This is all about thinking about the risks to reliability in the process, the green steps that I've just shown here. So in order to do this, the first thing we need to do is to take whatever product we're looking at and break it down. So that's what's done on the left-hand side within this oval here in these 4 steps. So maybe the product's got an operating process. Maybe the user has to do certain things when they use it. So list down what those steps are for using it, because then we can think through each step and think, how could someone do that wrong? Then break the product down into its component parts. So if I wanted to think about how this went wrong, if I looked at it as a whole, I might miss things. But if I break it down into its component bits and look at this cover that fits over the batteries here, and I look at the individual cells and the spring and look at those individually, then I won't miss things. So it's about breaking it down. The installation process, what are going to be the steps in installing it? Because they're opportunities to do things wrong. And finally, how am I going to make it? What are the steps in terms of making it? Because again, those are opportunities for getting it wrong. So that's about breaking it down. And on the right hand side of the circle, you can see where we apply a tool, or where we ask suppliers to apply a tool called failure mode and effects analysis. And that's about, it's about looking at the different bits of the design, like the cover, and saying, why is that cover there? What's it to do? Might be that it stops the batteries falling out and you're losing them. Yeah. And then to say, okay, well, what could go wrong with that? What would be the consequences of it and how severe would it be? And then to rate those consequences. Then to also think about the occurrence. How likely is it that a certain cause that might lead to that would happen, and then to rate the occurrence of it. And also to think about what controls they've got in place. Are there any tests and things they do during their design process in order to capture those, and then to rate how good those controls are at stopping that problem from happening. So they rate those, and then based upon the ratings that they put down for those, they prioritize them and think about what they can do to de-risk the product by changing the design to improve it. So those FMEAs, those are done for the design. They're also done for the installation process and for the manufacturing process. And this step here with the P on it, that's a robustness study. The reason there's a P there, it gets recorded on a thing called a parameter diagram. So that's why the P's there. But a robustness study is a little bit more subtle than an FMEA. You think not just about how a product might totally fail, but how it might just not operate as well as it should do. And you think about different sources of variation that might affect it. And these are the sorts of things that you might want to build into your tests. Remember what I said about running tests under perfect conditions earlier, and how you might want to think about what it's really going to see on the railway. This is where you start thinking about what those things it might see are. So you think about things like piece-to-piece variation. The fact that if I make 2 of these, there'd be some things on it that might vary. Wear out. The fact that things might change over time. So there's a little clip on this cover here. And as I put this on and off, maybe 20 times, this might start to get loose. So things that change over time. The environment, how that might affect it when it's on the railway. The effects of people, either users, operators, installers, and also interactions. And you list these down and you rate them, but it's a simpler process than FMEA. And for certain parts through the process, we accept that instead of the FMEA. For instance, with COTS products, it's acceptable just to do one of those robustness studies, or if someone's already got an FMEA, that's fine, we'd accept that. All about thinking about what can go wrong and trying to design it out. But of course, you can't always design failures out. It might be trying to overcome the laws of physics, or it might just be so expensive that you'd never be able to sell one. So therefore, that's why we come to this next step, step 834, which is about if you can't design a potential failure out, can you suggest some maintenance activity where we're going to maintain it to make sure it doesn't fail in that way? And that then leads on to coming up with a suggested maintenance regime. Because typically in the past, we've often had products where they've come from the supplier, the network rails just looked at it and said, well, how are we going to maintain that then? But the experts in this product, of course, are designing it and the people who are making it, and we're looking to them for suggestions as to how we maintain it. And then you can see underneath here, this is where we test those maintenance actions? Is it actually physically possible to do them? Somebody might say, change this seal every 3 years, but maybe you can't get the cover off, maybe you can't get in there. And there's a big gap between saying what the maintenance activities are and the time when you actually test them. The reason is you don't want people testing the maintenance activities on bright, brand new, shiny items. If we wait until later in the process, we've had the chance to test them, throw salt water at them, heat them, cool them, the grease starting to dry out on them. And so therefore, if we test those activities then, it looks a lot more like it would do to people on the railway who've got to follow these instructions later. The 2 steps in the circle there, that's where we ask the supplier to tell us how reliable they think the product's going to be. So they might say, I think this is going to have a mean time between failure of 40 years, either based upon evidence that they've got of prior products or maybe from various calculations from tables and things. And also if they think that's going to change, because maybe they've got some improvements in coming up in the process, and therefore they say, oh, we think the mean time between failure is going to improve in 2 years when we bring this change in. Or, of course, they might be aware that it's going to get worse. So maybe they know that there's going to be some trains introduced onto the railway with stiffer suspensions, the part will wear out faster, and we'd rather know about it now. That way it avoids any surprises later on where we go running around saying, why is this part failing? When, it's because we're loading it more. It's what would have been expected, and it's what we acknowledged at the point that we signed that product off. Of course, at the bottom of the diagram there is where we start to collect some data later on when the thing actually goes onto the railway to see whether it meets those targets. These blue bits are all about testing the product. So a lot of these steps aren't necessarily totally new for design for reliability, but it puts them into the context of the whole process. So the step in the circle is the supplier stating, here's all of the testing we're going to do, or if it's one of those off-the-shelf products, testing that we've done. And that relates to different things. So this first step is testing the components. So you might test that component part of this by fitting it and taking it off 100 times and seeing whether the ability of this to stay on deteriorates over that time. The step underneath it is testing it as a system. So building the whole thing up, connecting it up to the things that it sees on the railway and testing it to make sure it can work under those conditions. And then we get to the one that people tend to struggle with the most, that might be one of the newest steps to some people. That's testing of the manufacturing process. And what we mean by that is showing that something that's important to get right on the product, such as maybe that little clip there and the force that has on it, that because the dimensions of that might be very important when you make it, knowing that if you manufacture a large number of them, is there a chance that some of them will be outside spec? So maybe taking 25 of these off the production line, measuring them, comparing them against the spec and seeing whether they're all nice tightly in the middle there, not much chance of producing an out of spec one, or you've got a lot of variation and over time there might be a chance of producing a bad one. Also, any installation testing that we do might be that there isn't anything that we measure or test during installation, but if there is, that's where we do it on that next step down there. Railway trials. So why are we doing the railway trial? What is it that we want to measure? What is it we want to find out from that? And also to list anything that's going to be recorded during its early use. And of course, because we're measuring things, we need to record the results somewhere. So that's where we expect a DRACAS system to be set up, which is a data recording and corrective action system, where we record things that have failed, but also things that have succeeded. So if somebody has tested something for a long period of time and it hasn't failed, that's just as important to know as well, because that helps us to calculate the mean time between failure. And within that box I've just shown, the column on the right, that is that's there for solving problems. Might be that we do some testing and nothing goes wrong, but if something does go wrong and we need to fix something, that's where we go about doing it. Those are the gauge R&R studies and the calibration work I spoke about earlier. M means any of the measurements we take when we're manufacturing it, M for manufacturing. S is the product itself. So if we were buying a piece of measurement equipment, we want to know that that gives us the results that represent what's really going on. And the I on there, that's any installation gauges where we do it for that. Materials come in, so those purple ones I've just shown, that is where we expect suppliers to come up with the materials for showing how something's going to be maintained, installed and so on. So nothing particularly new with that step. And that's where product acceptance fits in there. Shown on there twice because of course somebody might go straight to full PA, but it might be somebody gets awarded trial product acceptance earlier on in the process and have to go through and do a railway trial before they reach full PA. So that's where that fits into the process. Then that step there, that one in green I've just shown, what this is that Network Rail has moved away from where we have people going and fixing things on the railway. When they fixed it, they used to get on the phone, ring up somebody at a control department that we had, tell them what they'd fixed, and somebody would tap it into the computer. Not necessarily a technical member of staff, and so therefore the words might get changed in terms of how it is reported. So we've moved away from that. We're moving towards using iDevices for people to type in their own work and record what they found. And so with that, we asked the supplier to supply a list of the ways in which something might fail. Of course, they've already done that because we had the FMEA earlier in the process, so we just expect them to pull it out of that. And the final step is this, just the supplier checking back with Network Rail to say, have we done everything that we said we would? So there's one final slide here that's there for you to look at afterwards. This just summarises here how the DFR process ties in with the product acceptance process. And you can see that near the beginning, there's a bit in grey. It's not compulsory, but that's where you can use the product acceptance submission form by typing into it DFR inquiry to find out from the product acceptance team what path Network Rail expect you to take through design for reliability and to engage with Network Rail early on. Thank you.
Thanks very much, Kevin. That was packed full of detail. Thank you very much. A couple of questions. I can hear myself echoing. Sorry about that. So the first question is from David Clark, and he asks, Kevin, you mentioned Network Rail's willingness to transfer learning, learning historic data. Are you happy to share with this? Are you happy to share this with a supplier developing something speculatively, or do they have to be in contract with Network Rail?
That's a good question because there's several aspects to that. First of all, we do have to be very careful with that data. We don't just pass it on in its raw form and give people direct access to it, because we do need to make sure no other suppliers are mentioned and so on, and there's nothing sensitive in there. But once we've refined it, we then pass it on. So in theory, there's no problem with passing it to somebody who's developing something for us. However, the only issue I have with the question is, of course, that if somebody is wanting to develop something for the railway, it needs to be something that Network Rail want. That's why these sponsors, the applicant sponsors that Roger mentioned about, have been introduced, because we don't want people developing something on spec for the railway, because they could spend an awful lot of money developing it only to find that Network Rail don't want it. So what I would stress to people in that situation is find a sponsor. Once you've got a sponsor and that sponsor says, yes, this is something we want, we're interested in it, then of course, no problem whatsoever. That's why that step is in the process and we do want to share it. But it's in the supplier or potential supplier's interest to find that sponsor, because I don't want sponsors spending an awful lot of money developing something that they're not subsequently going to be able to sell to Network Rail. And I'm sure they wouldn't want to put themselves in that situation either. Yeah.
Okay, thank you. John Lawrence asks, lots of people tend to get a bit worried about tackling DFR, design for reliability, with worries of cost and duration. This is actually quite linked to what you're saying. I tend to view it as a big plus for a supplier, but what would you say are the benefits to the supplier to following this process?
Okay, so clearly some of the steps in here, like the gauge R&R study, because although there's one risk there that somebody thinks something's okay, sells it to Network Rail and it's not okay, you've got the flip side where somebody thinks it's not okay and really it's perfectly okay. So they could end up scrapping parts, throwing them away because they're not aware of the quality of them. As I've just said, the fact that this gives them confidence because we've got this sponsor process in there. They've got confidence that they're more likely to sell something at the end of the day if they followed the DFR process. And also the DFR process pushes things early on in the process. It's all about engaging early on, and it's much cheaper to apply these tools early on in the process than it is after the design has been created, because making a design change at that process can cost many, many times the cost of doing it early on. So in terms of development costs, it can reduce that greatly by doing that. And of course, you can't really put a value on it, but you've got reputation cost as well. If a supplier provides something to Network Rail and it delays a lot of trains, or, you know, potentially could have a safety risk or something like that, if we can avoid that by applying design for reliability, the supplier will benefit from that because they're more likely to get repeat business, aren't they? If they've got a product that's been shown to be reliable and safe in the past because they've used known, tried and tested tools previously.
Great. That's actually all the questions. John Campbell had asked how DFR interacts with the PA process, but you've you answered that in your last slide. Oh, here's one here. What influence does the whole life cost have in the process? Is it more for justification of the change, or is there a particular target for what a good whole life cost should be?
Yeah, I mean, one of the columns that I didn't harp on about within the process there was there's a very long, thin column, which is supplier selection. Very variable, because sometimes we select a supplier very early on because we're engaging and contracting with them to develop something. Sometimes we contract with them late on because it's a product that's already been developed, it's a COTS product, and we're contracting with them to buy it. So it can vary greatly. Yeah. But in terms of the whole life cost, where that comes in is it's something that gets considered when we select suppliers. So if you are one of the suppliers and you've got other suppliers out there that have also suggesting that their product is something that we might want, when we're comparing with them, we come up with some scoring that we do during the supplier selection process, where one of the key factors in there is that whole life cost. So if you can show your product has got better whole life cost, you've got more chance of winning that contract. And on the DFR training course, we talk through that, even though it's sort of at the edges of DFR, we talk through how our supplier selection processes work. You know, we want to be transparent on that, explain to people how it works, how the scoring works and so on. And there's further information in there on that. Brilliant.
Thank you, Amelia, for the question. Now that we're just at 4 o'clock, I'm just going to do a very quick thank you. So thanks very much to everybody who's attended, and to a special thanks to David, Emily, Roger and Kevin for their very insightful, informative presentations. I'd just like to remind people that we'll announce shortly our Get Into Rail and final third event of the series shortly, so keep an eye out for that. And also we've got a hydrogen event with Arcola Energy in the University of St Andrews at the end of April, and a skills event with Skills Development Scotland at the beginning of May. So there are 2 further events to keep a wee eye out for in the future. And I think that's it from all of us at the Scottish Engineering team. Thanks so much, and thank you to RIA and Network Rail for a really great session. Thanks very much.